Algebra 1, Common Core, June 2016 Regents exam, starting on number 31 for this one. The formula for the sum of the degree measures of the interior angles of a polygon is S equals 180 times n minus 2. Solve for n, the number of sides of the polygon in terms of S. So basically giving you this equation, S equals 180 times n minus 2, and we want to solve for n. Meaning get n alone. Solve for n, get n alone. I want to have an n equals da 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 da. But I want n to be by itself. Not 2n, not 5n, not n plus 2, just n equals by itself. So how do I get n alone over on this right side? There's a couple of things you could do. I think some people would either get rid of it 180 to the other side right away, and I think some people would distribute the 180. It really doesn't matter. It will work both ways here. I think most people, when they see a number in front of these parentheses, their first thought is distribution, and that's not a bad thought here. So let me go with that. So S equals 180 times n, and 180 times negative 2 is 360. And then literally it's just solve for n. So I add 360 to the other side, add 360, so S plus 360 equals 180n. And as you know, 180n really means 180 times n. And, to get rid of that, the inverse operations, move it to the other side. So we're going to divide 180 on both sides. Divide 180. And now n's alone. And I'm just going to rewrite it, but this is what it equals. And I'm not going to worry about simplifying it or anything like that. So n equals S plus 360 divided by 180. I think another acceptable answer would be S over 180 plus 2. I think would be another possibility, because you could have divided by 180 and then just added 2 to the other side. But, either one would be accepted here. So it's just, it's just solving equations that have multiple variables, and it's just the concept of get one of them alone. And it's just do whatever you got to do to move things to the other side, the inverse operations to move things to the other side. 32. Given the graphs here of f of x and g of x is also graphed here. They want to know, they say the graph of g of x is the result of a translation of f of x. And remember, a translation is like a shift, left, down, left, right, up, down type of stuff. So they're saying f of x is translated. Certainly looks like it was shifted down to form g of x. And so they want the equation of g of x. Well, remember the rules for transformations real quick. I'll just cover that a plus or minus, or let me go through all of them real quick, that a plus on the outside is an up. A minus on the outside is down. A plus on the inside is left, which is what some people think it's the opposite. A minus on the inside is right. I mean, the other rules are, well, what if you, put a number in front of, the x, and this could be x squared, x to the third, square root of x, absolute value. It doesn't really matter. If you attach a number to the front, that is, narrow or wider. If you throw a negative in the front, that's when you do the flip. It's flipped upside down. So these are your rules. So moving down is a minus on the outside. So how much did it move down? Well, I think you're looking here and you're looking here. It moved down to negative 4. So down 4. So I want to take this equation and move it down 4. So all I got to do is take that. So this is going to be g of x. Take the x to the third plus 2x to the second and move it down 4. That's the answer. Now, if it were a left-right, that'd be way more complicated, because you'd have to do it inside with the plus 3 and inside with the squared. Raised to the third into the second, so that's way more complicated. The up-down shifts are just adding and subtracting on the end, not each thing on the end of the whole thing. So that's it. Explain your reasoning. Minus 4 on the end is a down 4 shift. Something like that would be fine. Okay, next question. Please, next question. Why is this not moving? There we go. Just check, make sure that button's working. There it is. The height h in feet of an object dropped from the top of a building after t seconds is given by this. Now, you need to be able to recognize equations and tell if it's linear, quadratic, absolute value, exponential, square root, that type of stuff. And as soon as you see an exponent of 2, that means quadratic. So we're looking at a parabola. Parabolas could either be smiley faces or they could be frowny faces. The negative attached to the front of the variable means we're dealing with this, which is often what they use for these word problems. And, we're talking about, a ball is thrown into the air and it makes this path kind of thing. Or here they're saying, and an object is dropped from the top of the building. So here's, the building's this high and it's dropped. Maybe it's thrown up a little bit and then it's dropped. So you're not looking at the whole curve, you're looking at part of the curve. But very common to use quadratics for these word problems. And it's very common for them to be negative quadratics because they model things a little bit better. So first question is, how many feet did the object fall between 1 and 2 seconds? So t represents time in seconds. So we could plug in a 1, plug in a 2, and compare. Or we could let our calculator do a lot of the work for us for this question. Let's try that. And so we want to type in negative 16t squared plus 144. And y equals negative 16, you got to use x instead of t, but that's okay, x squared plus 144. And just double check that's what it is. Negative 16 and plus 144, yes. And we could try to look at the picture, but we might have to manipulate our window a little bit. Really specifically, we need to see further up. Further up is your y max. Let's set it at 50 and see if we see things better there. I'm still not quite there. Let me go a little higher. Let me set it to, I'll set it to 150 and take a big jump. So there it is. Now, this whole part on the left is kind of worthless. We're just kind of looking here, and I could cut that off if I want. I could say, all right, set a minimum of 10. Looks like it's not going that far, so let's set it to, 6, and say, all right, here's an object being dropped off the top of a building. But your table is going to be very helpful here if you want to know the distance from t of 1 to something, and that's really x of 1. So at 1, it's 128. And what was the other number? From 1 to 2. All right, so at 1, it's 128, and 2, and it's 80. So the coordinates are 128, and 280. Now, it doesn't say determine algebraically, so I think I could get away with just having that answers from my calculator. But what you could do is you could show when you plug in a 1, the result is 128. When you plug in a 2, the result is 80. And when in doubt, just always show work there. But we want to know how many feet did the object fall between this. So if I draw a better picture here, we're saying, from 1 second, it's at 128, and 2 seconds, it's at 80. I just want to know, this distance, how much more did it fall from here to here? And so it's the difference of these. So it's 128 minus 80 is going to be 48. You don't have to write feet, but it's 48 feet. And then the second part says determine algebraically. So here is where they don't want you just to use your calculator. How many seconds it will take for the object to reach the ground. So when is it going to hit the ground? Again, I would probably first get the answer from my calculator and then algebraically confirm it. I mean, you look here, it looks like 3, but let me check that on the table. When I have an x value of 3, I have a y value of 0. So the answer here is going to be 3. And you always get a point just for the answer, even when it says algebraically. But if I want full credit, algebraically means show the work. So how do I get this? Well, when it hits the ground, we're talking about when when y equals 0. So what I could do is set this thing, I guess I'll stick with t for format consistency. Set it equal to 0, right? Because it's equal, like this is y, it's the height. So when is the height 0? And solve. Sorry, my t looks like my plus. Minus 144. You get negative 16 t squared equals negative 144. Divide negative 16, divide negative 16. And so t squared equals, this divides out to be positive 9. Square root, square root. Remember, when you square root, you need to have plus minus. So the answer is positive or negative 3. But negative 3 doesn't really make a whole lot of sense here. You can't say, you know, 3 seconds before the object's thrown, and it doesn't really make sense. So t equals 3 is going to be the answer. And 3 seconds after it's dropped, it's on the ground. Let me try to write that answer a little bit neater. Remember, you want to really make things neat here. If it's hard to read, grader might not give you the points. All right, 34. Let's see, do I got time to do this one? Yeah, let's try to get this one in real quick. Let's see if we can keep it under 13 minutes. The sum of two numbers, x and y, is more than 8. So the sum of two numbers is more than 8. When you double x and add it to y, the sum is less than 14. Graph the inequalities. Well, I want them to be in y equals form, so here I'm going to minus x. So y is greater than negative x plus 8. Remember, these are not like terms. You can't make it like negative 8x or something like that. And for mx plus b, I want the variable in front of the constant, so negative x plus 8. So that tells me to start at 8, and a slope of negative x is a slope of negative 1 over 1. And, you know, that's going to go in both directions. And then remember, solid or dotted, if it were equal to, it would be a solid line, but because it doesn't have the equal to, it's going to be dotted. So I'm just going to do that as I make my points here. And I like to just make a slash through like every point I would plot. And we are greater than. Using my y-axis, these are the numbers that are greater than it. These are the numbers that are less than it. So greater than, I'm going to shade to this side. All right, do the other one. I'll stick with green here. So here I got a minus 2x. Minus 2x. So y is less than negative 2x, then the positive 14. This is 8, 9, 10, 11, 12, 13, 14. And a slope of negative 2. Right, so that's down 2 over 1. Here, I'll make these dots. Looks like they cross there. I'll make that one extra big because that's where they intersect as dotted lines. But when it comes to inequalities, the intersection of dotted lines actually is not a solution. Intersection of solid lines would be. And this one's also less than. Oh, not also. This one is less than. So less than is the other side. So again, the greater than is less than is this. So all of this here. So there's a lot. And so the overlapping shaded region is this little area up here where they're overlapping here. I'll put a little S in there so you can see what I'm looking at. And make sure you label. So I'll label this one. This was y is greater than negative x plus 8. And the other one was y is less than negative 2x plus 14. I just want to double check. Was more than, less than. All right. So then the last question here is the point 6,2, or Kai says the point 6,2 is a solution to the system. Now 6,2 is that point I was referring to. It's right here. It's where they cross. Determine if he is correct and explain your reasoning. And the answer is going to be no. And we could say because it is on dotted lines. And that would be acceptable. That would be enough right there. And you know, really what it is, if you were to plug 6,2 in, like let's plug it in one of these equations. If I plug in 6,2, replace the y value with 2, the x value with 6, and it's negative x, so negative 6 plus 8, you end up with 2 is greater than 2. And this is false because it's not greater than or equal to. That's why dotted lines don't work. But if these were like less than or equal to, greater than or equal to solid lines, then it would be true. All right, sorry, I went over 14 minutes, but want to get this thing done. So we're almost there. 1 or 2 more videos, and we're done with the series. All right, see ya.